And we'll be recording from here on out. So I will work back through those examples because I'm just now recording. So anyway, so that you have this video, remember definition. So dividend is the number you're dividing. Divisor is what you're divising it by. Quotient is the answer. We worked through an example with whole numbers. We worked through a long, ugly problem with polynomials. And I walked through the first example of synthetic division. We're going to do a couple more examples of synthetic division, but for those of you that really needed this recorded, I forgot to hit the button. So we're going to do another problem. Actually, we're going to do a few showing another example of synthetic division. All right, so again, following the rules, we're going to synthetically divide x to the fourth plus 2x to the third minus 1x minus 1, and we're going to divide that by x plus 3. Again, this is where my divisor goes. And if you remember, if this is my divisor, we're going to grab this plus 3, but we're going to take the opposite. So if that's a positive 3, then we're going to put a negative 3 here. Then we're going to put our coefficients of the dividend here. This one has a couple of things you really need to pay attention to. Remember, if you don't see a coefficient, for example, this x to the fourth, you don't see a number in front, it's automatically a 1. Similarly, this minus x is a negative 1. Now, this is probably the biggest place where people got, okay? Remember how I said these have to be in order? It's also really important that you don't have anything missing. For example, if this is an x to the fourth, the next number is an x to the third, the next number is an x. What are we missing? We don't have an x to the second power. So we have to use a 0 as a placeholder. So if any term is missing, it is important that you put a 0 in there as a placeholder. So when I said these things have to be in order, I mean it, and you can't miss anything. So when we put our coefficients in, we're going to put in the 1, we're going to put in the 2, but because there is not an x squared present in the original problem, we got to put a 0 in there for the x squared term. Then we put in our negative 1, and then we put in our other negative 1. So for the x term and then for the constant. So again, any term that's missing, you got to make sure and put a 0 in as a placeholder. From there, the math is exactly the same. So you're always going to follow add. Get off of my screen. Add. And again, multiply. So negative 3 times 1 is negative 3. I don't know if you guys can see, but there's a thing that keeps popping up on my screen, like right where I'm trying to write, and it's driving me bonkers. Anyway, so add to get the 1. Negative 3 times 1 is your negative 3. Then again, we're going to add. 2 plus negative 3 is negative 1. Then again, we multiply. Negative 3 times negative 1. Put that number up here. That'll be a positive 3. And then we add. And then we multiply. And then we add. And then we multiply. And then we add until you run out of numbers. Then we've got to take this and rewrite it as a usable answer. So again, working backwards from right to left, this number is my remainder. This number is my constant. This will be my x term. This will be my x squared. And this will be my x to the third. So when I rewrite this, I get 1x to the third minus 1x to the second plus 3x minus 10 with a remainder of 29. Yeah. Yes. Yeah, because you're always adding it to nothing. So whatever your number here is pretty much does drop down because you're always going to add it to nothing, and because the first step is going to be to add. So yeah. Now, again, this is 100% what I'm looking for. So when it comes to the test, this is how I want to see the answers. Again, this is what I'm going to be wanting to see. My math lab asks for a couple of different versions of this or what it's going to look like. So if they say they want it in, this format, that's a Q. My crappy handwriting, that's a Q. All this means is, so this little dx represents your divisor. So that's the original x plus 3. Okay, we divided by x plus 3. So that goes there. This q of x, quotient of x, is the answer part. That comes straight from here. So again, that's your quotient. And then this r represents your remainder. So a couple of the problems, and it'll be obvious because the way my math lab says it, you'll see this. And in the prompt, they go ahead and put the divisor in, and then there's a blank to fill in here and here. But just so you know, this is what they're looking for. So this is the format they want you to type it in as. Again, for me, on the test, I don't care about any of that nonsense. As long as you can get here, this is what I'm looking for. I'm more worried about you getting to the right answer than all the different ways you can write the answer. But my math lab does ask for a couple of different things. Another way they ask for it is just qx and then r. Sometimes they say r of x. And again, they're giving you a couple of different boxes to put just the quotient piece and then just the remainder piece. So just if you see either of these things within my math lab, just remember the Q part always refers to the polynomial-ish part of the answer. And anytime you see that R, that's simply referring to the remainder, if there is one.
Can I ask a question?
Yes, you may.
I just want to ask before we move on, because I don't know if the next question will have this.
Okay.
Since our first term was x cubed, will we always in this circumstance or ones like it always go down a term like x cubed instead of x to the fourth?
Very good. Yeah, that's exactly right. Because if you look at the last example, this was the very first one we did. We went from an x cubed and then the answer was an x squared, right? So same thing, you're just dropping one term. And this problem went from an x to the fourth. When we divided, the answer became an x to the third. That does always happen. So as long as you're dividing by 1 power of x, your answer is going to be 1 power less per second. And all the ones we have set up are just like that. You're just dividing by an x plus 3 or an x minus 2 or something like that. Because I could throw something more elaborate in there, but that's not the focus of this course. So yeah, each answer is just going to be 1 power less than the problem you started with. Good observation. And again, this is primarily the two different ways the answers should look by my math lab. The one that kind of jumps out is like this one where they throw the divisor in as a factored form, but that's that. I'm going to do one more example of the synthetic division. And sometimes you get really big, scary answers, so I'm just going to make this one up on the fly. And we'll pick something that probably end up really gross. So let's say we had 2x to the 5th plus 5x cubed plus 10x divided by x minus 3. So again, I was kind of mumbling there. So that's 2x to the 5th plus 5x to the 3rd plus 10x divided by x minus 3. Same setup for our divisor. Again, we're going to grab the opposite of this guy. So if that's a negative 3, then we're going to use a positive 3. And then remember, it's got to be in order. And if anything's missing, for example, we go from x to the 5th to x to the 3rd. So what am I missing here? X to the 4th. Okay. And same thing, in between the x to the 3rd and then this x with no power, that's an x to the 1st. We're missing an x to the 2nd. And the one that really catches people is, okay, this is x to the 1st power. There's also supposed to be a number out here with no x's. So again, that's your constant. And we have to put zeros in all 3 of those places, because those pieces don't exist within the original problem. Well, they do, but they're gone. So we've got a 2, a 0, a 5, a 0, a 10, and a 0. So all of these zeros are necessary. And again, follow our pattern where we're going to add, multiply, add, multiply. Oh yeah, this is going to get ugly real quick. Add, multiply, add. Here's where I get to test my brain power. So 3 times 69 would be 210 minus 3, so it'd be 207, I think. Plus 10 would be 217. Times 3 is horrific. That'd be something. Luckily, I got my handy calculator here. 2 times 3. Oops. 651. And then we add. So occasionally they'll give you a problem like this. It really just throws some gigantor numbers at you. But again, the process is the same. And again, once we get here, we want to find a usable answer. So that's remainder, constant, x, x squared, x cubed, x to the 4th, which again, 1 power less than what we started with. If we started with an x to the 5th, my answer is going to be in an x to the 4th. So 2x to the 4th plus 6x to the 3rd plus 23x to the 2nd plus 69x plus 217 with a remainder of 651. All right. With synthetic division, we can also do something called synthetic substitution. Synthetic substitution is basically a way to do regular substitution, okay, but you're going to do it using the synthetic manner. So for example, let's say we have some function, f of x equals x squared plus 2x plus 1. And let's say I wanted to find the f of 3. There's two ways to go about this. One is the way we've already talked about. We did this in a previous section. Okay, if I want to find the f of 3, that just means to plug 3 in. So I can plug 3 in for those x's. So I can do 3 to the second power plus 2 times 3 plus 1. And I can follow order of operations. 3 to the second power is 9. 2 times 3 is 6. 1 is 1. 9 plus 6 plus 1 is 17. 16. Good. Poor math skills. 16. Okay, we can get that same answer using a different method. There's a thing called synthetic substitution. And it follows the same pattern of synthetic division. The only difference is, instead of grabbing the opposite, so say I wanted to figure out f of 3, I'm just going to use the 3. So we no longer grab the opposite. We're just going to take that number. But we still take the coefficients in order. So x squared x constant, 1, 2, 1. And again, we can follow that same pattern. So 1 plus 0, multiply, add, multiply, add. And this number should be the same thing. So it's one of those things, I mean, it's kind of like a math trick. You don't need synthetic substitution. You can evaluate a function in the exact same way that you've always done it and still get the right answer. This is just another way to do it. Okay, that always works. And it's neither here nor there, but it's going to ask you to evaluate some function. So again, within my math lab, here's a typical problem. They'll say something like, all right, f of x equals x to the 4th minus x to the 3rd minus 5x to the 2nd plus 3x plus 1. Let's do that. And say they want me to evaluate the f of 5 and the f of negative 1. So we're going to do these two problems individually. And honestly, I don't care. If you want to do this the long way and you just want to plug 5 in, I mean, you've got a calculator. Your calculator is built for just this kind of thing. Your calculator is built to calculate and to do so correctly. So you just plug your number in for x and evaluate it. You can literally type that in exactly the way it looks. So 5 to the 4th minus 5 to the 3rd. Oops. Helps if you turn your calculator on. And your calculator should generate the right answer. Mine says 391. Or if you want to do it synthetically, again, grab your number. My powers all fall in order. We've got 4, 3, 2, 1, and 0, so nothing's missing. I just grab my coefficients, 1, negative 5, 3, and 1. And then we just add, multiply, add, multiply, add, oops, multiply, got ahead of myself, add, multiply. Somehow I got 316. So I either typed something in wrong up here or I did something wrong here. Yeah, I did. 5 times 15 isn't 60, dummy. 5 times 15 is 75. So that should be 78. That's what happens when I start trying to do too much in my head. So then that's 390. And then I get the 391 that I was supposed to get. So My calculator did this one and did not make a mistake. I did this one and made a mistake. So there, that's how not to do it. Followed by how to fix it. So synthetic substitution works. I don't care if you want to do it the old-fashioned way. Old-fashioned. It doesn't matter, but you can synthetically evaluate. Another thing they're going to ask you is some number what you want to call a zero? So is 10 a zero, or is 7 a zero? Again, what that implies is if I plug 10 in for x, does that make my whole function equal 0? If so, then that's a yes. If not, then that's a no. And again, you can do this kind of the long way. So you can plug your 10 in. Ten squared is 100. 3 times 10 is 30. 100 plus 30 minus 70 is 60, which is clearly not 0. So no, 10 is not a 0. Same if you did the synthetic. You generate the same thing. Again, still not a 0. But the 7, if I did this right, should be. So we add, multiply, add, multiply, and add. So if the number makes the whole function equal 0, then yes, it is a 0. So that's really just a couple of things they could ask you. And again, the book is going to be looking for work like this. But if you want to plug it in the old way and just plug your number in and see if it works, that's fine. If we plugged 7 in, we'd get 7 squared is 49. 3 times 7 is 21. 49 plus 21 is 70. 70 minus 70 is still 0. So yes, you still get a 0 there. So in terms of substitution or plugging in, I'm perfectly fine with just plugging your number in or doing it synthetically. Now, the division that we started with, this is a much better method than long division. This is the method I would definitely recommend, especially if it's one of these ridiculous problems where you're going to get some whack-a-doodle answers. Okay, you're not going to want to do that long division-wise. Synthetic makes tons of sense there. But again, this is just a couple of different ways. They can ask you to evaluate a function, which again, you can just plug that number in or do the synthetic. Remember, if that's the case, don't take the opposite. We just take that number. Or they could ask you, is something a 0? Again, don't take the opposite. We just take that number. And then if we get a number, it's not. If we do get 0, then it is a 0. All right. That's 4.3. 4.3 is synthetic division and then synthetic substitution. That part goes really quickly. 4.4 is a much bigger topic. 4.4 is going to kind of run us around for a little bit. So we've got essentially kind of 4 different things we're going to work with. But one way I like to think about 4.4, the way it's starting out, is kind of working backwards. So everything we've done with our polynomials, we've combined like terms, we've multiplied, okay, we did some division, and then we talked about is something a 0. The way 4.4 is going to start is they're going to give you the zeros. For example, 1 and 4. And they're going to ask you to write polynomial second degree, okay, with the following zeros. So we're going to basically write the polynomial that would generate these two zeros. So like I said, we're essentially working backwards. Instead of being given a polynomial and then maybe finding the zeros, they're giving us the zeros and telling us to, or asking us to write the polynomial. So the way we do this is, again, we're going to do this backwards. So I want to get this on the same side. So the opposite of 1 is -1. So if I subtract 1, or if I subtract 4, basically what this does is this converts from my zeros to my factors. Okay, if 1 is a 0, then x minus 1 equals 0. So what that says is x minus 1 is a factor. Similarly, if x equals 4, well, then x minus 4 is 0, and then x minus 4 is a factor. And then if we multiply my factors together, so x minus 1 times x minus 4, or we FOIL this out, so that's x to the second, that's negative 4x, that's negative 1x, and that's positive 4. So again, we multiply those first terms, that's where that x squared came from. Multiply those outside terms, that's where that negative 4x comes from. We multiply those inside terms, that's where the negative 1x comes from. Then we multiply those last terms, that's where that positive 4 comes from. Combine our like terms, negative 4x and negative 1x is negative 5x. And then this is a second degree polynomial that would have zeros 1 and 4. So again, we're working it backwards. They're basically giving us the answers to start with and asking us to generate the function with those answers. And then they're going to progress. They're going to give us more zeros. So the next problem they would ask is something like, all right, can't do them left-handed, and I can't do it without having my hand in the way. So write a third degree polynomial with zeros -1, -5, and +6. So again, we know we're going to end up with a third degree polynomial, so we're going to have an x to the third at some point. And we know these are my zeros, -1, -5, and +6. So again, if -1, -5, and 6 are my zeros, then opposite of that, so x plus 1 is a factor, x plus 5 is a factor, and x minus 6 is a factor. Yeah, because if this is the thing that causes 0, so then -1 plus 1 is 0. So this is the factor if this is the 0. So yeah, the opposite. The factor is always the opposite sign of the opposite. So -1, +1, -5, +5, +6, -6. Yes. So then again, to find the polynomial, we've just got to multiply my factors together. So we're going to do this in stages. We're going to multiply these two guys together first. So again, we're going to FOIL first. X times x is x squared. X times 5 is 5x. 1 times x is 1x. And 1 times 5 is 5. Combine those two guys together, so that's x squared plus 6x plus 5. And we've got to multiply that times x minus 6, which again is even more distribution, so we've got x squared times x, which is x to the third, x squared times negative 6 is negative 6x squared. 6x times x is positive 6x squared. 6x times negative 6 is negative 36x. And then 5 times x is 5x. And 5 times negative 6 is negative 30. So again, we had to distribute all those. So we took that x squared times both of those. We took the 6x times both of those. We took the 5 times both of those. So that's where these all came from. And then certain ones of these we can combine because they have the same variables. So when it's all said and done, we get x cubed, negative 6x squared and positive 6x squared cancel each other out. Negative 36x plus 5x is a negative 31x. And then we've got negative 30. And then this is my third degree polynomial that would give me the zeros, negative 1, negative 5, and 6. Okay, the next thing they're going to do is they're going to give you a similar problem, but they're going to say it kind of funny. So write a third degree polynomial with the following zeros. Kind of hard to read that, I had to write it small. So 1, 0 is 2, but it says with a multiplicity of 2. Multiplicity just means it's repeated. So whatever that multiplicity is how many times that 0 is going to repeat. So again, if 2 is a 0, then what's my factor? X minus 2. And if there's a multiplicity, that just means it's going to happen more than 1. So in this case, it's going to happen 2 times. If it would have been a multiplicity of 3, you'd have another one. If it was a multiplicity of 4, you'd have 4 of them, okay? So the multiplicity just simply tells you how many times that 0 happens. So again, if 2 is a 0, then x minus 2 is my factor. And if there's a multiplicity, that's how many times it's going to happen. Yeah, well, that's the only time you'll see the word multiplicity is in reference to how many times a zero occurs. So basically, this is like saying you've got a zero of 2 twice. And then we also have a 0 of 0. And since there is no such thing as opposite of 0, like you're not going to put x minus 0, right? That would just be x. So if you have a 0 of 0, then the factor is just x, because you're not going to put, again, you're not going to put x minus 0. That's just x.
We're saying
Right. Right. So I probably should have chose a different number, but 2 is the 0. The multiplicity is what makes it happen more than once. So just for instance, I'm going to jump somewhere else. So if it would have been a 0 of 4 with a multiplicity of 3, okay, if 4 was my 0, that means x minus 4 would be my factor, and a multiplicity of 3 means it's going to happen 3 times. So again, the 0 becomes the factor. The multiplicity is how many times that factor shows up. Okay, so it's just another way to write it. So instead of listing the zeros out, they can do it by way of multiplicity. So again, a multiplicity of 2 means there's 2 of them. Multiplicity of 3 means there's 3 of them. Obviously, multiplicity of 4, 5, 6 means there's that many. So whenever we do our multiplication, you need to make sure you have both of those x minus 2's. So if we would FOIL that out, x squared, negative 2x, negative 2x, and positive 4. So again, with my hand out of the way, x times x, be x squared, x times negative 2, negative 2x, negative 2 times x, negative 2x, negative 2 times negative 2 is the positive 4. Again, combine, so x squared minus 4x plus 4. And again, we've got that other x. So if we distribute him, we're left with x cubed minus 4x squared plus 4x. So that would be my third degree polynomial that would yield the following zeros.
Can you pause? My computer glitched, and so I missed a lot of that.
Okay, yeah, and this is recording, so if you go back and rewatch this, you can watch it at that point, and you can pause all you want.
Yeah, that's fine. Thank you.
Okay, yeah, no problem. Yeah, so I am recording and we can go back and rewatch that, but yeah, that's fine. But if you go back and look, and hopefully you can get caught back up.
So on the 0, if we were doing 0 4 multiplicity of 3, we still have the 0 factor that we end up doing that 3 times.
Not if they didn't give it to us. So the question was, would we still have this 0 for the problem that I made up here? And in this case, no. Like in this case, the only zeros given was 4 3 times. Right. So because in this original problem, we had a 2 with a multiplicity of 2 and a 0, that's where this guy also came from. And if I was sadistic and just wanted to watch you like melt under all the pressure, I could give you a problem with like 37 zeros and watch you have to try and multiply that whole thing out. It's like I can even do something simple like a 0 of 1 with a multiplicity of 37, and having to FOIL that whole thing out would just be horrendous. But luckily, I'm not a sadistic person. On a test, I don't think I'll do anything bigger than a third degree polynomial. So this would be pretty much your biggest multiplication. Now, I can't guarantee for my math lab that they don't give you a 4th degree or something like that, but it's not difficult. It's just, man, it's a lot of having to do the same thing over and over and over again. Now, like I said, we got to cover some ground because this is all nice and well as long as we get pretty little whole number zeros. All of our zeros were 4 or -1 or 5 or something like that. You can also have irrational zeros. If you have irrational zeros, an irrational number is just a decimal that doesn't stop or repeat. So that would be an example of something like 1 plus square root of 3, or 5 minus square root of 2, or just like the square root of 7. So that would be an example of an irrational zero. Now, one of the laws of irrational zeros is that if 1 plus square root of 3 is a 0, so is 1 minus square root of 3. They come in pairs. So irrational zeros are always going to come in pairs. And the only thing that changes is the sign. So like 1 plus root of 3 is also going to go with 1 minus root of 3. 5 minus root of 2 is also going to go with 5 plus the root of 2. Square root of 7 is kind of like saying 0 plus square root of 7. So then that's going to also go with the minus square root of 7. These are what is called the conjugate, okay, which is just a fancy way of basically saying the exact same thing, just with a different sign. Plus to minus, minus to plus, plus to minus. And irrational zeros, again, always come in pairs. So if you have an irrational zero, you're always going to have the conjugate, assuming you did things correctly. So they could ask us, so write a second degree polynomial with a 0 of square root 2. Okay, and the fact that this is a square root tells me this is irrational. And because it's irrational, it's going to come in a pair. So if square root of 2 is a 0, so is negative square root 2. So again, any kind of square root is going to come as a pair. And then in the same way, we're going to work backwards. So if this is my 0, then my factor is going to be the opposite of that. So if that's a positive root 2, then my factor is x minus root 2. If my 0 is minus root 2, then my factor is going to be x plus root 2. So then if I want the polynomial, I've got to multiply this together. All right, same pattern here. X times x, still x squared. X times root 2 is x root 2. Negative root 2 times x is negative x root 2. And negative root 2 times positive root 2 is negative root 4. So again, multiplying. X times x is x squared. X times root 2 is x root 2. Negative root 2 times x is negative x root 2. And negative root 2 times positive root 2 is a negative root 4. Now, the good news about multiplying conjugates is these middle terms cancel out. pretty much every time. In fact, I do think it is every time whenever you multiply conjugates together. Because you should always, because everything's the same except for the signs, you should get the positive of something and the negative of the exact same thing. So then we're just left with x squared and then negative root 4, which, what is the square root of 4? Square root of 4 is 2. So then this would be my polynomial. All right, similar problem, but with more stuff going on. All right. So let's say they asked me to write a third degree polynomial, and they gave me the zeros of 0 and 1 plus root 3. Now again, this is going to be a key. If it's a third degree polynomial, there should be 3 zeros. They gave me 1. Okay. They gave me another one. But we're missing our third 0. And remember, the square root 1's come in pairs. So if 1 plus root 3 is a 0, so is 1 minus root 3. Okay, so again, this is what we were given. This is the initial prompt. So write a third degree polynomial with the zeros of 0 and 1 plus root 3. So I just wrote down the 0 and the 1 plus root 3 again. And then remember, as a square root, it comes as a pair. So 1 plus square root 3 is going to pair with 1 minus square root 3. And again, a key is going to be this third degree polynomial. Third degree tells you I should have 3 zeros. So that should just be a reminder. It's like, oh yeah, those things come in pairs. I need the other guy. So again, these are my zeros. So to get my polynomial, I need to rewrite these as factors. So again, if 0 is a 0, x is my factor. And now follow me, this is going to get gross real quick. If 1 plus root 3 is my 0, then x minus 1 plus root 3 is my factor. So again, that's x minus 1 plus root 3. And same, if 1 minus root 3 is a 0, then x minus 1 minus root 3 is my factor. So again, whatever your 0 is, x minus that. So I had to write it kind of small, and I don't know if you can see that very well. So x minus 1 plus root 3, and then x minus 1 minus root 3. And now I'm going to go ahead and do this. It'll simplify things a little bit. Actually, no, we'll just go this way. Yeah. All right. So this minus outside of this parentheses, technically we can distribute that. So again, this is going to be x minus 1 minus root 3. Same, if we distribute that minus, we'll get x minus 1 plus root 3. And then because these are what we call the conjugates, I'm going to multiply them together because you're going to see stuff kind of cancel out. So instead of distributing my x first, I want to multiply these two guys together. So if I multiply this, I get x squared. I get minus 1x. And I get positive x root 3. Okay, if I multiply this negative 1 here, I get negative 1x, positive 1, and negative root 3. And if I multiply this, I get negative root 3x, or negative x root 3. I get positive root 3. And I get negative root 9. So again, that was all the distributions. And hopefully we see some stuff in here that's gonna cancel out. For example, x root 3 and negative x root 3. Those two things are opposites. Cancel each other out. Negative root 3, positive root 3. Those two things are opposites. Cancel each other out. And then we get x squared. That's a negative 1x and another negative 1x, so that's a negative 2x. And positive 1. And negative root 9. Square root of 9 is a perfect square. Square root of 9 is 3. So 1 minus 3 is negative 2. So a long way around to get there, but not so horrible an answer once we find out our stuff that cancels out. And if we distribute our x, we get x to the third. We get a negative 2x to the second. And we get a negative 2x. And again, like I said, this part is kind of horrible. Nothing is too difficult other than trying to keep track of all of the stuff that you're having to multiply and then seeing what you can end up canceling out and what doesn't cancel out when it's all said and done. But when it's all said and done, you should end up with a fairly simple polynomial. And then it's going to generate those zeros. And to me, that's one of the ugliest problems in the whole chapter. Having to do something like that, just not much fun. It's math. None of it's very fun, but there you go. All right, changing gears. Again, very similar to irrational zeros are if they give us a non-real or a complex zero. Remember from previous algebra classes, non-real or complex numbers imply something as imaginary. For example, 3i, or 1 plus 2i, or 5 minus I, something like that. This I stands for the imaginary number. It's a square root of a negative 1. It's what makes it complex. And just like irrational, non-real zeros come in pairs. And in the exact same way, it's the conjugate. So if 5 minus I is a 0, so is 5 plus I. If 1 plus 2I is a 0, so is 1 minus 2I. And if 3I is a 0, so is negative 3I. These are also called the conjugate. So in pretty much the exact same way that irrational zeros come in pairs with opposite signs, so do your complex or non-real zeros. Okay, so again, they're going to ask you to write a second-degree polynomial with one of the zeros being 1 plus 3i. Again, the first thing we have to understand is if 1 plus 3i is a 0, so is 1 minus 3i. Again, non-real complex zeros always come in pairs. 1 plus 1 minus. And just like before, if these are my zeros, step one is to rewrite them as factors. So my factors are x minus 1 plus 3i and x minus 1 minus 3i. And again, that's almost exactly like what we did with the rationals. Okay, x minus the thing, x minus the thing. And guess what? We get to play that same game. So if we distribute our minus, we get x minus 1 minus 3i. And if we distribute our minus, we get x minus 1 plus 3i. And then it's a whole host of distributions. So again, multiply this x times all three terms. So x squared minus x plus 3xi. So again, that's x times x times negative 1, x times my 3i. Same, we're going to take negative 1 times all three pieces. So negative 1 times x, negative 1 times negative 1 is positive 1. Negative 1 times 3i is negative 3i. And last but not least, so again, we multiply negative 3i times x is negative 3xi. Negative 3i times negative 1 is positive 3i. And negative 3i times positive 3i is a negative 9i squared. And again, the way I do this when I'm looking for stuff, I know stuff should cancel out. So I'm looking for another one of those guys. So positive 3xi and then negative 3xi cancel each other out. Negative 3i and positive 3i cancel each other out. So I get an x squared negative 1x and another negative 1x is a negative 2x. And I got this positive 1. And then I've got this negative 9i squared. Now, another thing that happens with imaginary numbers from previous algebra classes, I squared. So there's some explanation behind it. If I is the square root of negative 1, you square that, then this is no longer imaginary. I squared equals negative 1. So what this I squared is a negative 1. So that really just changes your sign. So this is x squared minus 2x plus 1 plus 9. So again, the I squared changes your sign, and now it's no longer imaginary. So negative 9i squared just simply becomes positive 9. And then I can combine it with the 1. So I'm left with x squared minus 2x plus 10. So again, non-real zeros come in pairs. If 5 minus I is a 0, so is 5 plus I. If 3i is a 0, so is negative 3i. So when they give me a 0, I automatically know the conjugate is 1. Rewrite those as factors. Go through the process of distributing each term times the other 3. Cancel out your opposites. Combine your like terms. I squared simply changes negative 9 to a positive 9. Again, combine like terms. Final polynomial. Do one more of those, and then we've got one last topic to cover. All right. So they're going to ask us to write a third degree polynomial with zeros of 4 and 2i. Again, this should be a hint, third degree polynomial. We need 3 zeros. They gave us 2. They gave us 4. And they gave us 2i. But we know that your imaginary ones have to come in pairs. So if 2i is a 0, so is negative 2i. And again, if I want to come up with a polynomial, I know my zeros. I need to be able to rewrite those as factors. That would be x minus 4, x minus 2i, and x plus 2i. Okay, and then again, I'm going to multiply these two first because they're my conjugates. I could multiply these two guys first, but then I've got to deal with more imaginary numbers. This is where stuff is going to cancel. This is going to be a better problem to start with. Again, distribution, x times x is x squared. X times 2i is 2xi. negative 2i times x is a negative 2xi, and negative 2i times positive 2i is a negative 4i squared. Again, I'm looking for stuff to cancel, positive 2xi and negative 2xi. Those guys equal 0. So then this is just x squared. And remember, again, that I squared just changes my symbol. So negative 4i squared is really just positive 4. If I just bring this guy down, then I can just finish my multiplication to get my third degree polynomial. Again, distribution, x times x squared, x times 4, negative 4 times x squared, and negative 4 times 4. Now, I think my math lab would let you type it in this way. I'm okay with this answer. If you want to put it in descending order, then the squared should come before the x. But to me, that's neither here nor there. All right. The last concept of 4.3 is actually a whole section in and of itself. At least it is in every other class I've ever taught. But they just tacked it on here like it's just an add-on, which is kind of funny because this is it's not funny, it's a big topic. So again, everything we've done to this point, they've either given us a factor, or they've given us a 0, or they've given us something to work with. What they're going to ask us to do now is they're giving us a problem, and they want us to find all of the possible zeros. So they're going to give us something like x cubed plus 3x squared minus 2x minus 6. Now, in previous classes, we had factorable problems, which always ended up with pretty little neat answers. This one's not always the case. So to attack this problem, we've got to do a couple of different things. Okay, first off, we've got to understand I guess I should say rational, not real. All of the possible rational zeros. That says rational. If you can't read my chicken scratches, R-A-T-I-O-N-A-L, rational zeros, is all of the factors of this guy divided by all of the factors of this guy. So the factors of 6 are 6, negative 6, 3, negative 3, 2, negative 2, 1, and negative 1. So that is the plus and minus of all of the different numbers that you can multiply to get 6. You can multiply 1 and 6, or you can multiply 2 and 3. And you have to account for both the plus and the minus of each. Divided by the factors of this one. So now luckily, if you divide a number by 1, you just get itself. So really all of my possible zeros are plus or minus 6, or plus or minus 3, or plus or minus 2, or plus or minus 1. So again, that's all of my possible rational factors. Those are my only choices. Now, the crazy thing is I've still got, what, like 8 different numbers to choose from, and not all of them are going to work. So again, the degree tells you the number of zeros you're going to have. So this only has 3 zeros. And this only guarantees that this is a possible rational 0. So you could still end up with a positive root 2 or a negative root, anyway, something like that. What we're going to do is we've got to try these numbers until we find a 0. So for speed, I'm going to use synthetic substitution, and I'm just going to kind of start working backwards through these until I find a 0. So from my original problem, x to the third, x to the second, x and negative 6, I don't have any missing terms. So I'm going to use 1, 3, negative 2, and negative 6. And I'm looking to find a 0. So I'm just starting with the smaller numbers because they're going to be faster to work through. So I'm going to try positive 1. So going through the pattern of synthetic, add, multiply, add, multiply, add, multiply, add. Okay, that's not a 0. 1's not a 0. And unfortunately, trial and error is kind of the best way to get through this. So I'm going to try negative 1. So again, add, multiply, add, multiply, add, multiply, negative 1. Also not a 0. All right, I'm just going to start trying something different. I'm going to try 3. Add, multiply, add, multiply. And I'm actually going to stop here. Once I realize I'm to an 18, okay, I'm not going to end up back here at a positive 6, which is what's going to make this 0. So I know that's no good. So as soon as you realize you're not there, there's no sense keep going. But if I work this out right. All right, I finally got one. So negative 3 is a 0. So if I tried negative 3, again, with my original problem, so this was my original problem, and then my prompt was to find all the zeros. So this was my list of possibles, and I found one. Now, the good news is once I have that one, while I could keep guessing, it's actually going to be easier to solve for the remaining 2. So if negative 3 is a 0, and if I did my synthetic division, okay, remainder here, constant x, x squared, okay, this is my remaining answer. So I've just got to figure out what would make this x squared minus 2 equal 0. So if I take x squared minus 2, I can just use algebra to solve this. Add 2 to both sides. Remember, so synthetic, the question was where did the x squared come from? Remember synthetic division, so this number is my remainder. This number is my constant. This is my x. This is my x squared. So my remainder was 0. My constant was negative 2. My x, there's a 0 there. There's no need to write it. And then 1x squared. So it came from that old synthetic division from last section. So again, x squared minus 2. Add 2 to both sides. How do I get rid of the squared? square root. And remember, whenever you square root, you have to account for both the plus and the minus, which you can write it together or separate. But in any case, there's your zeros. So, original prompt, find the zeros. Again, this number here tells me how many I'm looking for. I know there should be 3 zeros. This step gave me the possibles, which I tried until I found one. Once I found one, I took what was left over and solved.
On that last one, on the zero, would that not just be an X?
I'm not sure which zero. The question was, would that zero not be an X? Which zero you're talking about? This one here?
Yeah.
Yeah, that's why I didn't bring it down. So if you can kind of zoom this out. So 0 is my remainder. I don't need to write it. -2 is my constant, so I wrote it. 0 x's, I don't need to write 0 x's. They're just gone. And then I had 1 x squared. So that's where that came from, kind of step by step. And then again, if I'm solving this, I want to know what's going to make this equal 0. And that's where I got that. We'll do another one of those. So again, the prompt will be find all possible zeros. And they'll give us some kind of polynomial. So 3x cubed minus x squared minus 57x plus 19. Okay. Again, my possibles are going to be all of the factors of this guy divided by all of the factors of this guy. Now, while 19 is a big number, it's also prime. So what is the only thing you can multiply to get 19? 19 and 1. Plus and minus. And you can list them, positive 19, negative 19, positive 1, negative 1, or the plus and minus is just a short way of saying both of those. And similarly, the only thing you can multiply to get 3 are 3 and 1. So all of my possible rational zeros are 19 divided by 1, or negative 19 divided by 1, or 1 divided by 1, or negative 1 divided by 1, or negative 1 divided by negative 1. Anyway, you still get those. Or 19 divided by 3, negative 19 divided by 3, or 1 divided by 3. So these are all of my possible rational answers. So 19, negative 19, 1, negative 1, negative 1/3, 1/3, negative 19 thirds, 19 thirds. These are all of my possible rational zeros. Which again, we know it's not all of these because there's only 3. But we need to find one before we can really get started. So again, that's where we go into the whole trial and error. And I typically like to start with the ones and the negative ones just because as far as the math goes, it's just easier. Multiplying by 1, multiplying by negative 1 is easy. So I'm going to try one. So again, looking at my original problem, I got 3, I got negative 1, I got negative 57, and I got positive 19. I guess I didn't need the plus there. But I'm going to see if 1 works as a 0. So add multiply, add, multiply, add. Okay. Obviously that doesn't work. I can figure out what this number is, but it's not going to be 0. So all that told me is that 1 doesn't work. And I'm going to cheat because I did this problem and I walked through all of it and I tried doing all the ones that weren't fractions and they didn't all work. But I'm going to try 1/3 and we'll see. So again, if I add and then I multiply, so 1/3 of 3 is 1. Add, I get 0. 1/3 of 0 is 0. Add 1/3 of -57 is -19. 19 minus 19 is 0. So 1/3 is a 0. So I know I'm looking for 3 zeros. I found one. So one of my zeros is going to be 1/3. Now, again, once I found one of my zeros, the easiest way to go about this is to take what I have left over, and then we're going to solve it. So again, this is my remainder, constant, x term, x squared term. So a remainder of 0, don't have to worry about. Okay, -57, 0 x's, don't need to worry about that. And I've got 3x squareds. So again, this 3, 0, -57, and 0 equals 3x squared minus 57. So this represents this as a factor. Which again, I need to figure out what makes that equal 0, because I'm looking for zeros. Again, the prompt, find the zeros. So I need to know what numbers make this equal the 0. So we're going to solve again, add my 57 to both sides. Divide by 3. To get rid of my squared, I'm going to square root. And when you square root, you have to worry about both, whoops, the plus and the minus. I wrote 13, that's cool. So plus or minus root 19. So my zeros are 1/3 square root of 19 and negative square root of 19. Now, the good news is they only threw one of these problems in my math lab, and it's a cubed problem, so it'll play out just like this. Also, on your test, I will choose an x cubed problem, and it'll play out just like this. So while I've seen problems where it was like a 5th degree polynomial, and they made you do this a whole bunch of times, again, I'm not sadistic. I just want proof of concept. So if you can solve this, you could solve something bigger with more time and more motivation, but I don't have you the motivation to give you solve something bigger than that, nor do I want to grade it. So I can also tell you that it might ask you for something else. So again, if these are the zeros, sometimes it'll ask you for the factors. It's exactly what we did before. So kind of in the whole working backwards thing. All right. If my 0 was 4, my factor is x minus 4. If my 0 was 2i, my factor is x minus 2i. Okay, same concept. If 1/3 is a 0, then x minus 1/3 is a factor. Or they might want you to write that as 3x minus 1. So if we multiplied everything by 3, anyway, either of those are fine. Again, I'm perfectly fine with this. My math lab may want you to get rid of the fraction, but I don't know why, because this is going to be a radical. So this is going to be x minus root 19. That would be your factor. And this would be x plus root 19. That would be your factor. So if they ask for the factored form, it's just changing your zeros back into factors. It's just a notation thing. So that was 4.3 and 4.4. 4.3 was a lot more straightforward. It was just the synthetic division and synthetic substitution, which synthetic substitution you don't have to do. You can just plug in. 4.4 is loaded with lots of stuff, and it's very confusing if you're not paying attention. One thing that I'm going to tell you that will help you out, by the way, you can't use it on the test, obviously, but if you get hung up on the homework and you're just dying trying to find these zeros, if you Google, okay, polynomial zeros calculator, you can find something that will find all the zeros for you. You can literally type this in, bam, hit enter, and it'll find the zeros for you. And then you can kind of work backwards, but that way you're not throwing away points on your My Math Lab. I don't want you to have to do like 4 of these problems because you made a silly mistake somewhere, okay? Or maybe you tried 1/3 and you didn't think it worked because you made a silly mistake with a sign error, okay? So I don't want you dying because you can't get one little piece, because without one little piece, you can't really progress. Does that make sense? So kind of like photo math. I mean, you guys probably know more ways to cheat about math than I could even begin to tell you. But on your homework for My Math Lab, you can use that stuff to make sure that you got the right answers, but just understand you can't do that kind of stuff on the test, okay? But for My Math Lab, to make sure you got the points and to make sure you're not just like flailing away at a problem that you can't really get anywhere, that at least gives you somewhere to start. So anyway, if you Google zeros calculator, there's a bajillion, 70, 11 of them out there, and you can find one that'll work. Okay, that's all I got for you guys. Again, this is recorded, so I'll load this up to Canvas so you have it. Anyway, see you guys next Thursday. Also, as a reminder, next Thursday we finish up. So next Thursday we'll do 4.5 and 4.6, and then I'll do a quick review, and then we will test the next time. So we test in 2 weeks, so be ready for that. See you guys.